Okay, last but not least, we also need to look at how do we write a thermochemical equation for a chemical reaction that has taken place. So they say, for example, write a complete thermochemical equation for the combustion of ethanol. If they give you the question just like that, they will have to give you a table with all the values. Now, I went and got these values out of the table for combustion. Now, if we look at the table and we want to find out how much ethanol is being burned or combusted, we would have to find out what is the combustion value for methanol, and it is minus 1,367 kilojoules per mole. So as I've said, either they would have to give you that combustion value, or if they don't give it to you in the question, they would have to give it to you on a table. This one was given in the question and it comes out of the textbook. So if I want to write this chemical equation for them completely, I will use this formula. This is ethanol, C2H5OH. It burns in oxygen, it forms carbon dioxide and water. Once you've written this out, remember that you also need to put in the phases. So methanol or ethanol is in a liquid form. It burns with oxygen, which is a gas, forms carbon dioxide, which is a gas, forms water, which is a liquid, and it could also be in gas state. Now you have to know this is what happens when you burn anything in oxygen. It forms it burns with O2, it forms CO2, forms H2O. No matter what it is that you combust in oxygen, this will be the byproducts. You then have to go and balance the equation. So if you look at the purple, that's what I had. Then I had to go back and then I had to balance everything. Make sure that my numbers of carbons, hydrogens, oxygens on the left equals to what is on the right. And I could do that by putting a 3 in front of oxygen, a 2 in front of CO2, and a 3 in front of H2O. This value that was given to me in the question, I then have to write it behind that equation in the correct way. So delta H for combustion is equal to negative, sorry I squeezed it in there, negative 1,367 kilojoules per mole. So you write that at the back of the equation. I suspect that if this is asked of you in the exam, that you would be given marks firstly for writing the correct combustion reaction by writing that it reacts with oxygen, forms CO2, forms H2O. Secondly, you'll be given a mark for balancing it correctly, and please make sure when you write the equation that you put the phases in at the bottom in brackets. Sorry, this L here is not in brackets. I didn't put it in brackets, so my mistake, but you must put it in brackets. You will also be given a mark for writing this correctly at the back of the chemical reaction and indicating the negative because it is a exothermic reaction. The questions that were given to you, number 27, is also very simple. They want you to indicate whether it's exothermic or endothermic. So they indicate to you in the first one that this goes from a liquid state to a gas state. So when something goes from a liquid to a gas, liquid to gas is vaporizing. So anything that goes from a solid to a liquid to a gas is endothermic. So that means it's an endothermic reaction. If you look at this one, bromine, don't even worry about the elements in front. We're just looking at the phases. From a liquid to a solid. Liquid to a solid means it's going from there, from a liquid to a solid. Liquid to a solid is freezing. So from gas to liquid, from liquid to solid is always going to be exothermic. Heat is given off. You've got to lose energy all the way down to become solid again, and that means energy given off. So freezing is an exothermic reaction. So when I go from liquid to a solid, it's freezing, and therefore this is an exothermic reaction. This is combustion. Because it's burning in oxygen, combustion is always exothermic. If you look at this one, goes from a gas phase to a liquid phase. If you go from a gas to a liquid, we call it evaporation. From a gas, condensation. From a gas to a liquid, condense. To condense and go to a liquid state, you need to lose energy so that the particles can start moving slower. So this is an exothermic reaction. The last one, you're going from a solid to a liquid. When you go from a solid to a liquid, the particles have to gain energy. Because they need to go from solid to a liquid, they need to move further apart, they need more energy, so they absorb energy. Absorption of energy is endothermic. So for this question, you didn't need to even consider the chemical reaction. You just had to consider the phase change, and in this case here, the fact that it's a combustion reaction.